Jamb candidates, welcome to today's lesson, and today we are looking at the shortcut of finding sines, trigonometric sine, okay, the value of trigonometry, the common trigonometric sines, okay, because you are going to encounter, whether you like it or not, you are going to encounter this either in maths or in physics, okay, where you have sine 60, sine 90, sine 45, sine 30. How are you going to find the sine if you don't know them? The calculator that you are going to be given in your Jamb UTME, you are not going to find sine inside. It's just those basic plus, minus, and square roots. That's what you are going to find inside the calculator, okay. So you have to learn this. It's very easy. I want to show you the shortest cut. So if you need any material, you need any help for this Jamb UTME preparation, send me a message. This is my WhatsApp number. This is my WhatsApp number. Okay, send me a message on WhatsApp. Let's talk. All right. So it's easy. If you are working on sine, all you have to do, just draw a hand like this. You see the way my hand is like this. Draw a hand like this. This is a hand like this. So then label the hand from sine, from this one, this thumb. Okay, label from 0, 30, 45 degrees, 60, 90. As simple as this, like this. Okay. If we are doing cos now, for example, you are going to start this one from 90. That's this 0 now. You are going to, it's the same thing for cos, but it's the numbering that will change. You will now put this 0 here and you will start from here. 0, 30, 45, 60, 90. If it's cos. But since you are working with sine, it's like this. And you are numbering from here. So we are going to apply the formula, the square root of finger below. That's the number of finger below. Okay. The square root of the number of finger below over 2. That's the formula we are going to apply. Very easy. Square root of the number of finger below over 2. Okay, so for the first now we have here is 0. What is the number of finger below this 0 degree? We put our root. Okay, what's the number of finger below? We have no number of finger below, so we are going to put 0. Okay, over what? Over 2. According to the formula, and this will give us what? 0. All right, it's sine. Okay, 0 degree. Okay, so the next one is sine 30. Sine 30 degrees equal to how many number of fingers do we have below 30 degrees? Root. We have what? 1. Just 1. Okay. Root 1 over 2. Okay. And this will give us what? Root 1 over 2 will give us what? That's going to give us 1 over 2, right? 1 over 2. All right. So the next we have here is what? Sine 45. 45 degree. Okay. And what do we do? How many finger? The square root of how many? The number of finger we have below for 45. How many do we have? 1, 2. Just 2. Okay. Root 2 over what? 2. You can use this to solve like this. Okay. The next we have here is sine 60 degrees. Okay. How many finger? The number of finger we have below 60 is what? 1, 2, 3. 3. Root 3 over 2. Okay. Then the next again we have is what? The final one, sine 90. You can do this one now. Do sine 90 and drop it in the comment section. All right, let's look at cos next. You remember what I told you about cos, okay? That is the opposite of sine. So the finger, the palm is still like this, okay? You put the hand like this, but instead of it to start numbering from 0 degrees like this, 0, 30, 45, and so on, because it's cos, we will now number from here. 0 will now be here. 0, 30, 45, 60, 90. Look at it. 0, starting from the pinky finger. 0, 30, 45, 60, 90. So this one is for cos. So we are still applying the same formula, which is what? This square root of what? Number of fingers, okay, number of fingers below, square root of number of fingers below over 2. It's still the same formula we are applying. All right, so how do we solve? Which one we go do first? Okay, make we do 90. Okay, cos 90. All right, so cos 90 degrees is equal to square root of how many fingers below? We have 0. Okay, so nothing over what? 2. So this, and the next is cos what? Cos 60 degrees equal to what? How many fingers do we have below? Root 1 over what? 2. All right. So the next we have is what? Cos 45. Cos 45 degrees. How many do we have below 45? 1, 2. Okay, that's 2 over 2. Root 2 over 2. That's cos 45. Then the next is cos what? Cos 30. 30 degrees, which is equal to how many fingers do we have below? 1, 2, 3. 3 over 2. That's root 3 over 2. All right. The final one we have is what? Cos 0. Okay, cos 0 degrees. Okay, you do cos 0 degrees and drop it in the comment section. We are looking at resistance in what? Series and parallel. Okay, we are looking at what? Resistance in series and parallel. All right. So I want you to know something in physics that is very constant. Okay, apart from capacitor, okay, resistance in series and parallel in anywhere is the same. Anywhere they are the same. Okay. Even if you are talking about impedance, you are talking about inductor, okay, inductors in series, inductors in parallel, whatever, anywhere you find anything series and parallel, even if not battery, provided it's not capacitors, it has the same arrangement as resistance. Okay, so it's only capacitors that is different, that is opposite of this one. So resistance in this one is resistance in parallel. It means that, okay, because you can see the diagram. When you say something is connected in parallel or current in parallel, or this one is current in parallel, this one is resistance in parallel. It means that it has a branch connection. Okay, okay, but let's leave this resistance in parallel. Let's look at resistance in series, because resistance in series is straight. Okay, so resistance in series means that it is straight, it's connected straight. Okay, all the resistors, okay, all the resistors are connected straight. Look at it like this one. See first resistor here, resistor 1, resistor 2, resistor 3, connected straight. Okay, no branching, it's just straight connection. Okay, so in a circuit diagram you can see both resistors connected in series and also resistors connected in parallel in the same circuit diagram. So you just have to know the one that are connected straight and the one that have, you know, different branches and connection. So the moment you start having branches like this one now, you can see that there is a connection here. This one join here, this one join here, this one join here. It's now called what? Resistance in parallel. Okay, that's the difference. Okay, so every other aspect of physics, whether inductor, whether current, battery, connected in series or parallel, just know that it's the same, it has the same principle, the same arrangement as resistors. Okay, but when we are talking about capacitors, is opposite of this one. So when you say capacitors in series, it means that it is connected like this. That it has branches, branch. When you say capacitors in parallel, it's connected like this, straight. It's not parallel, that is straight in capacitors. So you apply the same formula. Okay, it's the same kind of pattern of formula that you are going to apply, but you just have to know the one that is series and parallel in capacitors. I told you that it's opposite, but apart from capacitors, the rest, inductor, battery, any other one, is what is the same. Okay, the same arrangement as resistor. Okay, so just use this resistor as your base. Use it as your base. Use it as the landmark. Okay, as the clue to finding every other one. Okay, so that's it, as simple as that. So the formula, when resistors are connected in series, that's straight, you just add up all the resistance 1, resistance 2, resistance 3, add all of them together. When resistors are connected in parallel, like this one with branch, what do you have to do? This is the formula. Number of the resistors, resistor 1, resistor 2, resistor 3. Then you do 1 over, you do 1 over, total, like this one, the total resistance, okay, is equal to 1 over R01 plus 1 over R02, depending on the amount of resistors connected in what? In parallel. All right? So I want you to note that they can as well connect all this together, like I explained before, connect everything together in the same circuit diagram and tell you to calculate it. What you have to do first of all is to calculate the total internal resistance. That's, you are going to calculate the resistance in series separate. Okay, you calculate this one separately, then you calculate resistance in parallel separately following the formula. Okay, after that you will now add up both of them, you plus 2 of them together to get the total internal resistance. Then if they ask you to find volts or they ask you to find current, you cannot apply Ohm's law. Okay, you cannot apply what? Ohm's law. Remember, Ohm's law relates what? It relates potential difference, which is volts, it relates resistance and current together. Okay, so depending on what you are looking for, you make, you know, the whatever the subject of the what? The formula. So let's look at the shortcut of solving this resistor in parallel. So when solving this resistor in parallel, let's say R01, they gave you 1, R02, they gave you 2, R3, they gave you 3. Okay, all right, so 1, 2, 3. So you take your, first of all, since it's 3, the shortcut, some people, they do LCM, but I don't like doing that LCM. It's a waste of time. So just pick 2, the R01 and the R02, you solve 1 over what? 1 plus 1 over 2. Okay, that's it. All you have to do, first pick 2 first, solve 2. Okay, the answer you get from 2, you will now use that answer to solve with 3, the same method. I will do it for you now. What are we going to do here? You are concerned about this what? This denominator. Okay, just what you have to do is to what? Times the denominator and plus the denominator. When you times the denominator, you form a numerator. You plus the denominator, you form a denominator. Okay, so 1 times 2 will give us 2. Okay, over 1 plus 2 will now give us 3. Okay, so we have 2 over 3. Okay, then we are left with one final one, which is 3. Okay, so we are now going to be left with something like this, 1 over 3. Because this one is fraction now, like this. Because it's fraction, we got the answer in fraction. If we want to make this, if we want to follow, you understand, to just follow this rule, okay, we'll just do 2 divided by 3. So 2 divided by 3 will give us 0.666, okay, that's, let's just say, approximate, you round it up, and you are going to get 0.67, all right, 0.67, you round everything up, you are going to get 0.7, all right, 0.7. So we are now going to be left with 1 over 0.7. And we will now use this 1 over 0.7 that we got from this one to solve with this 3. So it will now be plus 1 over 3. Can you see? So we'll now do the same thing again. This one times this one. Okay. So 0.7 times 3. So that will give us 2.1 over 0.7 plus 3. 0.7 plus 3. That will give us 3.7 over 3.7. Okay. So if we divide this one, what is it going to give us? 2.1 divided by 3.7. That will give us 0.567. Okay. 0.567. You approximate this, you add this to this, it give you 0.57. You carry 1, add on to 5. So we are now going to be left with what? 0.6. Okay. 0.6. All right. Easy. Okay. So we've gotten the what? The total internal resistance between R1, R2, and R3. As simple as that. But if you want to solve it with this fraction, okay, like here that you have the fraction 2 over 3 plus 1 over 3. Okay, you just do your addition of fraction now. You do your addition of fraction.